Hi guys, this is Anmol Talwar and welcome back to another video with Talent Catalyst AI, where we strive to give you industry-specific artificial intelligence knowledge which will surely help you grow in your career ahead. With a work experience of over 7 years, I have handled projects related to natural language processing, artificial intelligence, machine learning, and generative AI across industries such as banking, pharmaceutical, financial, as well as marketing technology. So, let the learning begin.
So today we'll talk about the biggest buzzword in the tech industry or anywhere nowadays, which has taken the world by its power. We'll talk about generative AI and what was the need of it and why are companies, every tech giant interested in that, and why are they investing so much to build large language models such as Llama 3, GPT, Starcoder, Gemini, Falcon. Why are these large language models being developed or being trained on billions of parameters, and all the tech companies such as Google, Tesla, Facebook or Meta, OpenAI, Apple are racing towards building such large language models to keep up their pace. So let's try to introduce and define generative AI. So generative AI is a type of artificial intelligence. So over here we have the artificial intelligence as a superset and generative AI as the subset of artificial intelligence. Artificial intelligence is nothing but trying to mimic our human brain or biological intelligence. Over here, we have the biological neuron, which works on the principle of learning from the historical data or historical patterns and trying to do things in the future, trying to make decisions based on the historical complex patterns, making decisions in the future or in the present. This is what a biological neuron or our brain works in that fashion. Similar to that, mimicking its working or the process on how it works, we have artificial intelligence or the artificial neuron, which is the fundamental part of a neural network, which forms also the fundamental part of any artificial intelligence model, right? Of this whole superset of artificial intelligence, we have generative AI as a subset which helps creating any type of content which includes text, image, audio, video, or any synthetic data. As it names, as the name of generative AI suggests, it's an AI that helps in generating content and essentially original content. If we go a further deeper, generative AI can also be called as the subset of machine learning that enables computers to create original content. As I said earlier, original content, that content can be anything ranging from text, image, audio, video, or synthetic data based on the patterns learned from the existing data. So the definition of machine learning is essentially it tries to learn patterns from the existing data or the original data and tries to predict the future, right? Of that whole superset, generative AI is used to create original content which can range from any of these 4 to 5 categories, and it helps in every industry, be it music industry, be it content creation, be it art, be it robotics, be it healthcare, be it pharmaceuticals, banking and finance. Everywhere we have applications for generative AI. Let's discuss some of the most popular use cases of generative AI across industries. The first one is text generation, wherein generating contextually relevant text, and that particular text can be a sentence, that can be a paragraph, that can also be an entire article, right? Some of the examples of text generation are newsletter generations, email generations. Email generations can be customized using generative AI, using fine tuning for each and every customer so that the response is better. Then chatbots. Chatbots can help in question and answers, wherein given a question from a customer, the text is being generated as a form of an answer, right? Summarizing documents. Summarizing, if let's say you have a document ranging from 100 to 1000 pages and you don't have the time or the efforts to go through it all, you can ask generative AI models to summarize it for you so that your time is saved and you have an effective reading of that particular document, the main points, right? Coming to the second one, that is image generation, creating realistic images either from scratch or modifying existing images. So you might have seen a lot of applications that apply generative AI models of by creating images by just giving a, by we as a customer just giving a prompt let's say an astronaut riding on a horse, if we give that prompt, any bizarre prompt, that will create an image. That is the power of generative AI. Some of the examples of image creation generation that can be used in the industry is in advertising, so that creating such creative images can help gauge the audience better. Similar to that, in social media, creating novel images or creative images can attract more and more audience, and that same thing of image generation goes for gaming as well. The third thing is music generation. It can help create any style or any genre of music. Let's say I want to, as a music director for a film, I want to create a music, indie pop music for a sci-fi thriller. Just a bizarre example. If you give that prompt to a generative AI model specifically trained for creating audio or music, it can create that. What are the benefits of creating that? First of all, that particular music will be brand new. Nobody would have used it earlier, so it is totally royalty free for you. It doesn't have any copyright issues. It can be used in both social media, entertainment industry, advertisement industry, everywhere, irrespective of the industry. Coming to the fourth one, video generation. Giving a prompt to a generative AI model to generate a video is also one of the most popular use cases. It can be used in gaming, it can be used in advertising, it can be used in social media for creating novel and creative videos to attract more and more audience. Then coming to creativity, art and creativity, creating novel designs and appealing visual sculptures and digital art. That is what how generative AI helps in art and creativity. Let's say you are a product manager in a company, you don't have the time to create a PPT, you just want a base PPT for you ready. You just ask the generative AI model to create a PPT, let's say related to artificial intelligence and its use cases. It will give you a base PPT over which you can work, reducing your time and effort. You are a new company, an entrepreneur, you want logos which cannot have trademark or copyright issues. This generative AI can help, flexes, and many more things. Coming to the history of generative AI, why do we need generative AI and how did it come into picture? Natural language processing and the algorithms for solving natural language processing have gone through a series of advancements during the over the past few years. Initially, all the problems related to natural language processing were being solved using word count based algorithms such as bag of words, TF-IDF, right? Since these all algorithms were being trained on word frequency and word count, they lacked one particular thing, that is the semantics of the language or the context of the language. I'll try to explain that with an example. Let's say you are a customer and you want to buy, let's say, slippers from any e-commerce website, let's say Amazon. You want to buy slippers. In the search bar, you type slippers, right? In the back end of Amazon, let's say you have 50 slippers items registered, right? But the names of those slipper items are flip-flops. They are named flip-flops, right? There are 50 different items for the product that you want, but the name, the essential name of that particular, all those 50 products is mentioned as flip-flops. And if the algorithm, the search algorithm in Amazon that was initially there, if it was based on word count or the word frequency basis, and if you search for slippers in that, you will get zero matches. Nothing will get displayed because it will try to match slippers at the back end, the exact text slippers at the back end of the Amazon, and you will get zero results. This is what context means, or semantics, or the similarity of words. Now, if we had implemented that particular search engine using context based or embedding based algorithms such as RNN or LSTMs, which have semantics embedded into them, then entering slippers would have given you all the 50 options which had flip-flops written text embedded into the backend of Amazon. The reason is these context or embedding based algorithms work on semantics, that is synonymity of the word, right? Since flippers, slippers and flip-flops are the synonymous words like kitten or cat, similar to that, only context based or semantic based algorithms would help doing that. Though these algorithms, the context-based algorithms, that is RNN and LSTMs, they were able to solve the problem of semantics, which was there in the word count-based algorithms. They still had problems in generating the semantics or contextualizing long sentences. That is, if there are sentences of, let's say, 1,000 words as compared to a sentence of 100 words, if these context-based algorithms such as RNN and LSTMs were to perform on a sentence of 1,000 words, they'll not be able to capture the essence or the semantics of that particular sentence. For instance, if there is a sentence of, let's say, 1,000 words, the first word and the 1,000th word, they'll not be able to capture the similarity between first and 1,000 words. This happens because of a vanishing gradient problem, right? This particular topic we'll discuss deeply in the upcoming deep learning videos. The second problem with these particular RNN and LSTM was that they were sequential algorithms. Each and every token would go into these algorithms in a sequence, one by one. They didn't have parallelism embedded in these algorithms. There was no parallelism. These were the major two problems with these RNN and LSTMs. The two major problems with RNN and LSTM, that is context-based or embedding-based algorithms, were solved by the advent of transformers, which essentially work on attention mechanism, which was introduced in a paper in 2017. The paper was named as Attention is All You Need. In that paper, the first time transformer architecture was introduced, which essentially works on the self-attention mechanism, which is solved the problems, the two major problems, that is capturing the long range dependency, the longer sentences. The context-based algorithms were not able to capture the essence or the context with respect to long sentences. That is one problem. The second problem was not having parallelism while processing the natural text. These were the two problems which were solved by transformers. So transformers are the type of neural network architecture that gained popularity due to their effectiveness in processing sequential data and capturing long range dependencies. So sequential data was also processed by RNN and LSTMs, but the only problem with them doing it was they were not able to capture long range dependencies. The second problem was parallel processing of the sequential data. They used to do the processing one at a time, wherein transformers introduced parallel processing. That is mentioned over here. Apart from parallel processing, they had even deeper architectures as compared to the context or embedding based algorithms such as RNN and LSTM, which helped capture them even richer and more complex contextual information, and that too bidirectionally. So, what is self attention based on which the transformers work? Self attention is paying attention to different parts of the sentence while understanding it. It is like a spotlight that moves across each word, focusing on its neighbor words to figure out how important they are. This is essentially how self attention managed to solve the problem of long range dependency. Even if there is a sentence of, let's say, 1,000 words, the first word and the 1,000th word, self attention acts as a spotlight which moves across words. So, what will happen is this first word will have its context related to each and every word, be it the 100th word, be it the 200th word, and so on till the 1,000th word. So it will capture essence of that particular word related to each of those words, even if the sentence is very long, and hence self attention is able to capture long range dependencies. Each and every word is being correlated or being contextualized with each and every word, whatever is the length of that particular sentence. Right? We'll discuss self attention deeply in other videos, other upcoming generative AI videos.
Please do not forget to like the video and subscribe to the channel for more such informative videos related to artificial intelligence. Thank you.